Alrighty, I finally got a starfish access, so we can actually mark attendance now. Which also means that from now on we'll be marking tardies as well. So try as best you can to be on time. Alright, let's go through this. Alpha? Cool. And also, if I mispronounce your name, please let me know so I can get it right the next time. Kadar?
Here.
Yep. Justin? Sweet. Sandro? Cool. Aaron? Christian?
Here.
Fisher. Christian Fisher. Cool. Jakylin? Yep. Calvin?
Here.
Freddie? Matthew? Sweet. Donovan?
Here.
Cool. Christian Johnson? Sweet. Kadar? Johnson. John? Massey? Cool. Jamel? Jamel. Alright. Idris? How do I pronounce it? Idris? Or?
Yeah.
Okay. Cool. John Olinga? Cool. Mark Ross? Sweet. Rashad? Zachary? Which do you prefer? Zach? Cool. Help me out here. Nehemiah? Nehemiah? No? Okay. Khalik? Jamal? Alright. Oh, sorry. Khalik? Wilkes? No? Okay. Paul Wilson? Alright. And you saw my email response last night? Cool. And Isaiah? Cool. And then is there anyone that I didn't call? Alright, and what was your name? Troy. Oh yeah, Troy Boxon. Okay. I just got access to Banner Web, so I should be able to do like the course override and let you in. Do you prefer this 11 a.m. section?
Yeah.
Okay. So Troy Boxon, 11 a.m. And you were able to join the @STEM, correct? I think I saw that. Okay, sweet. Yeah. Okay. Anyone else I didn't call? Cool. Let's get into it. All right, variables, part 2. So again, because variables are a super important concept, we're going to dedicate one more lecture to it. Also because some people have just joined the class recently. I just really want to make sure everyone is up to date on data types and variables. We will literally be using these two concepts in every piece of code you do for the rest of your life. So overview, we're going to do a lecture 2 and 3 recap. Some of it will be, familiar, and that's good. If it's a little bit boring for you, that means that you probably understand the concept, but it still doesn't hurt to see it one more time. We're going to then extend variables and talk about variable reassignments and contrast them to string literals and numeric literals. We're going to talk about cin. So in your lab, you did cout, which stood for console output. Does someone want to take a guess what cin stands for? Console input. Yep. So right now, we've only printed information out to the user, but we also want to get information from the user so that we can customize the programs to what the user actually wants. And then finally, we're going to go into actually naming variables. Any questions before we jump into it? All right, let's do it. Okay, so we're just going to quickly play the game again. What's the data type? You've seen these slides, but instead of putting it on the top, I have kind of just put in the details. So does someone want to take a guess what data type this is? Int. Why is it an int? Whole numbers, no decimal places. What are some examples of ints? 5, 2, 12, 7. Negatives, yes, they can be negative, -3. It can be 0. They just can't be a decimal point. So numbers without quotes, no decimal points. All right, how about this one if it does have a decimal number? Double, yes. The textbook will also call it a float. In this class, we'll just be using double. Doubles can store more information than a float, and computers anyways convert floats to doubles. So we'll just use double. And then some examples, right? Anything with a decimal point. Notice even with this -40.0, 0.0, they look like ints, but because that decimal point is there, it's a double. And so when we some of the examples we used with the car example, miles per gallon, right? Even though a lot of companies just advertise it as 22 miles per gallon, Some companies will use 22.5. And so we want the data type to encompass kind of every situation that we can imagine for that. All right, how about text surrounded by quotes? String? Yep, you can remember it is a string of characters. And so even if it's a number like 42, as long as it's in double quotes, it's still a string. Also, when we talked about creating variable names, if you put a variable name in double quotes, it becomes a string. And the final one? Bool, B-O-O-L. And this only takes two values, true or false. All right, any questions on the summary for our first four data types? Okay. Cool. Does anyone remember what is a variable? What are some of the components of a variable? Yeah, Shikhan.
A unique name stored location and holds that.
Yes. All right. So breaking that down into three parts. Uniquely named. So we get to come up with the names for these variables. And at the end of today's lecture, we will actually dive into proper naming conventions. And there are like some small exceptions that I'm going to have you all be detectives and try to figure out what you can name a variable with. But for the most part, it can be almost anything you want. Uniquely named storage location. So we're going to go over those slides again just to see how a variable is mapped to memory location. And that memory location holds a piece of data. So let me put up the definition again. And again, the big thing that sometimes trips people up is the variable isn't actually the value, it just is a storage spot for that value. And the value can change during the run of a program. But we're going to dive into those slides a little bit deeper. So again, we saw these slides on Monday, but just for the sake of repetition, I'll go through it one more time, but I'll have you walk me through what's happening. So the compiler sees this code. They see string player. String is the data type. Player is the variable name that we have created. What does the compiler do with this information when it sees this line? Yeah. Paul?
It assigns it a certain number of bytes based off of how, like, the data type. So if it's like a string or a bool, it'll give it like bytes.
Yes, exactly. So each of these boxes in memory represents 1 byte. Computers can have billions of bytes in memory. And so exactly as mentioned, in the case of a string, it will set aside a certain amount of space based on how long the value is. In this case, because we don't have a value assigned, it'll just dynamically save some part in memory, and later we'll adjust the size. But if this were to be an int, it would set aside 4 bytes of data. If it was a double, it would set aside 8 bytes of data. So that's why we have to specify what the data type is. And then the compiler under the hood is also going to make a mapping to it. So in this example, it sees player and it will say, okay, we will put player up in this memory location. So we as programmers don't have to remember where each of these memory locations are. The compiler will take care of it for us. So the only thing we have to remember is the name of the variable, which is much easier to do than remembering these massive numbers. Yep, everyone with me? All right. Okay, and so variable assignment, this is where we can actually store data in these memory spots. So the compiler will see the word player. It's like, I remember, I put this in my mapping. So it will go back and see, okay, player is stored in this location. So it'll come here and it'll say, let's put in the name jaw starting at that memory location. And each byte of memory can only hold 1 character. So it'll put the J here, put the A here, and then the null terminator. I'll do a quick, interesting pivot. When we were talking on the first or second day of class, we talked about how computers use machine language or binary, meaning that everything is stored in zeros and ones. So how is the computer actually remembering like the letter J? J isn't a 0 or 1. Does anyone want to try to take a guess on how it might be able to store the letter J? Yeah.
So the binary code for the letter J, I don't know it off the top of my head, but that's what is actually stored there, and then J is a true representation.
Cool. Okay. So we have this principle called ASCII, A-S-C-I-I. This is kind of extra information, so you don't have to worry too much about it, but it's just to provide some cool context for what's actually going on behind the scenes. So ASCII will take every character. I think on your keyboard there's something like 180 characters, that's possible, and it will map each of those characters to a number. So I believe capital J gets mapped to like the number 16. And the letter A might get mapped to, I think it's 60, but don't quote me on it. Like there's a whole chart online that will map each of these characters to a number. But even here, 16 and 60, they're still not in zeros and ones. So it has to go another step further. This is what we call like decimal. Decimal format is the numbers that we're used to, 16 and 60. But we then have to convert it to something called binary, which is zeros and ones. And so how can we do that? There's like this really cool system where it takes all the powers of 2. So like 2 to the 0, 2 to the first, 2 to the second. And so 2 to the 0 is 1, 2, 4, 8, 16, 32, 64, 128. And with the sum of these, you can get to any number that you want. So, you know, if we wanted to do the number 60, that would be 1 count of 32, 1 count of 16 to get to 48, 56, 60, and then everything else will be zeros. And so this number 0, 0, 1, 1, 1, 1, 1, 0, 0 is actually equal to 60. And you could do that for anything. So for the value 16, so like this is equal to A. For the value 16, that one's easy because we just have the value 16 already. So there'd be a 1 there, and everything else would be zeros. And so just with these, what we call bits, 8 bits, you can get up to the number 255. Like if we put a 1 for each of these and you sum them all up, then it'll be equal to 255. And so we can literally get any number from 0 to 255 just using zeros and ones. Again, you don't have to like memorize it, and if it's confusing, don't worry too much about it. But I think it's kind of cool to see that like instead of the J here, actually what's being saved is like this binary number. Like each byte can store 8 bits of information, so it would store 0, 0, 0, 1, 0, 0, 0, 0 in the J, and then it would do the same for the A. And then this null terminator is just all zeros, all later zeros. All right, any questions on that?
So basically, you're saying like every value has it's like an alphabet. It's like its own language in itself, basically. Like every value has like a different code.
Yep, exactly. And I can actually just pull up like the ASCII chart to show you what it looks like. So there's like this table, like the null terminator is equal to 0, 0, 0. And then let's see like capital, okay, so the letter A. Okay, so A was actually 61. And there should be one that also has their binaries as well. Okay, yeah. So like this is a full chart where it looks like there's 127 total characters, and each one will have a decimal number and also a binary number. So yeah, octal Hask. Yeah, again, you don't have to memorize it, but that's essentially how the computers store everything in their memory. Cool. Any other questions before we move on? All right. Sweet. So this part was kind of review so far, so we kind of sped through it a little bit. Now I'll like slow things back down, and we'll get into some new material. So we talked about assigning player is equal to jaw. That stores it in memory. But over the course of a program, that value can change. And so you can have multiple assignment statements in a piece of code. In this example, we had player is equal to jaw, so jaw used to be stored in that memory location. But then in the next line, we change it to a different name, like player is equal to bow. And so now the name jaw is completely gone. If we ever call player in the rest of the code, it's going to return bow. Yeah.
Wait, so if we wanted to like have multiple assignments for the same type of variable, do you just put like player 2?
Yep, exactly. So you beat me to my question. I was like, what if we still want to store the name jaw? We would have that as its own variable player, and then maybe we'd create a new, as you said, like player 2 is equal to bow. That way we have both pieces of information saved. Yeah, so if you want to store multiple, just create multiple variables. Any other questions? Okay, this example looks a little bit silly. Like, why don't we just set bow equal to, like, in the beginning? But as you'll see in the lab today and in next week's homework, for stuff like, I have like a bonus problem in the lab where you're calculating the total cost of a meal. And so first for a meal, you first have to calculate the tax and add that to the total. Then using that new total, you calculate the tip, and then you add that to the total. So in that example, the total keeps changing during the course of your program. And that's where we would do this variable reassignment, where we keep changing the value. All right. Any questions there? Okay. So I'll give people like 30 seconds to take a look at this code, and then we'll see what the outputs are. Okay, so this is just like a visualizer to help see what's going on in the memory. This blue box kind of represents memory. And so the compiler knows, okay, age is equal to some int value that we haven't assigned yet. After line 6, what's going to be put in this value? 34. Cool. And so what's going to be printed out here?
Zach is 34 years old.
Yep, Zach is 34 years old. All right, now what happens after line 9 runs?
35 is assigned to the age.
Yep, and what happens to the 34 in that age spot?
Disappears.
Yep, disappears. So now, 34 is no longer part of the program. And what's the output here?
Age, colon, 35.
Okay, age colon 35. Okay, and why was it not just 35 colon 35?
Because it's in quotes. Position.
Yeah, so even though this age variable is this, like the text is the same, notice the distinction, right? On this side, there's quotes around it, so it just gets printed as a string. And on this side, when there's no quotes, then it gets used as a variable. And when it's used as a variable, it goes and looks at what the value is in memory. And so that's why it prints out 35 here. Are there any questions on this example? Okay. There's like a lot of subtle things going on in the code, which, after you see it run, you're like, okay, that makes sense. But part of it will be before it runs, trying to figure out what's going to happen. And that's how you know that you truly understand what's going on. Sweet. Okay, we're going to get into the next concept, which is the idea of a variable versus a literal. We've been touching on this without actually naming it. So in this example, we hopefully all know what variables are now. In this case, int age. This was the variable definition. So age is now a variable everywhere else in the program. And so whenever you see the word age, not in double quotes, that's how you know it's a variable. But the new concept that I'm going to introduce now is this idea of literals. And there's two types of literals, numeric literals or string literals. The 34 that's listed here, that's an example of a numeric literal. Once that's typed in the code there, that literally never changes. You just type in 34, and when the computer stores the source code, it's just stored as 34, right? Those two specific numbers right here won't change. Even though age here changes to a different literal, this 34 is always the same. Same with this quote, Zach is. That's a string of characters. That's a string literal. We type it out there. It never changes. Years old with the \n, that's another example of a string literal, where we type it out. It doesn't get stored in memory. It just, in this case, gets printed out directly to the user. Based on this example, help me fill out these last two lines. What are the variables there, and what are the literals? Yeah, Troy?
35 is literal.
Okay, and it's a numeric or string literal?
It's a numeric literal.
Okay, cool. Next, yep.
Age and course starts with string.
Yep. This one here with the age and the colon, that's a string literal. Cool. And then, okay, so that covers all the literals, and then which ones are the variables?
The variable is age.
Yep. So age on the left side of the equal sign, and then age here are the variables. Yeah.
I'm also curious, so like, so let's say if you wanted to put a quote inside of your string.
Okay.
So like not necessarily, like all strings already have like a quote around it.
Yep.
But like, what if there is a string that like has to have a quote?
Yes.
Like saying somebody said something.
Yep. Great question.
How does that go?
It was in the homework for people who've done it. Do you want to? Yeah.
I think you put like a slash.
Yeah, so
Like a slash in between the line.
it's
Yep. Do you want to build on that?
the escape command.
Yep.
That's what it said.
Yeah. So kind of here we have an example of an escape, what we call an escape sequence, where it's a backslash followed by an N. That's just stored as one character. It's not two. Like even though there's two symbols, in memory this gets stored as one special character, and that character means new line. And so if you want to do a quote, you would do a backslash and then quotation marks. And that will be stored as one special character. That's the quotation character. And so I released the homework on Monday. It's due next Monday. And there's actually that exact problem where I have you like print out a quote that someone said. And I've attached some reading to it as well so that you can see exactly how to do that. Mm-hmm. Yeah.
Speaking of that,
Mm-hmm.
speaking
Yeah.
of the homework, right?
Yeah.
What if you did? What if it works, right?
Uh-huh.
And it's like the exact same thing. But the problem is just not. I don't get it. I really don't get it.
Okay. I'll take a look at it after class here. So just hang back. Okay. Cool. Any other questions here?
Let me just get it.
Okay. Okay. Does anyone know the definition of the word vary? Yes, change. So it's like, how are you feeling? It varies based on the weather. It changes based on the weather, right? So that's essentially how you can remember the word variable. It's like changeable. This is kind of definition from Merriam-Webster, to exhibit or undergo change. And so in the context of computer programming, like a variable is a value that can, undergo change, and it might change throughout the course of a program. Whereas a literal, this isn't like technically, but the way I kind of remember it is like it literally doesn't change, or like it's just literal there. Don't quote me on that, but that's like an easy way to remember it, I guess. And so if we were just to compare and contrast, uniquely named storage location that holds data, and that specific data can change over the course of the program, either through variable reassignments. I guess that's really the only way. You assign a new value to it so that it can change. Whereas literals is a piece of data that's just directly written in the source code, and that particular piece of data doesn't change. And the last thing I'll add on this slide is that usually the value of a variable is equal to some literal. And so if we I'll come back to this slide so people can jot it down, but just going back really quick. In this example, right, age is a variable, age is on the left side, and we assign it to a numeric literal. And later we assign it to a different numeric literal. So generally it's like these literals that are being stored in memory, or the literal can just be printed out directly without storing it in memory. All right, I'll put this up for like 30 seconds. Does anyone have any questions? Also this code at the top, like int x equals 5, it's kind of combining two statements, right? Normally we have int x, and then on the next line we have x equals 5. We'll kind of learn more about it on Friday, but you can combine them in the same line if you want. and that can just save a little bit of space recoding. But you don't have to worry too much about that today. We'll cover that more in detail on Friday. Cool. All right, we're good on time. All right, so I'm gonna have you get into groups of 2 to 4 again. You can move the chairs around, and I'll pass around some paper, and I just, put a line down the middle, and on one side you have variables, on the other side you have literals, and just write down all the literals and variables as a group. Before one go together here. For what? The slides. The slides for today. So it'll be on that headstone link. I put I'll on headstone, like the
variables would be the things that are being called, so double MPG, which is gallons, which is
Yeah, that's true. The stuff under it ain't variable, like double one variable.
I haven't put up on my slide full,
I think the literals
Oh my god, I'm sorry. Oh wait, nah,
miles would be we're identifying the whole thing.
yeah. Also, if you finish this, also write down what the output will be of the code.
Yeah, so it's a wood for if MPG is correct and numbers began is 2.5, 20 miles. Double MPG.
Like those are all like changing or taking on different values.
50 miles.
Least amount.
All right, I'll give people 1 more minute. Wrap up.
And then you can drive it.
Okay, let's bring it back. All right, we'll kind of go around group by group and line by line. So we'll start here. First line here, any variables or literals? MPG. All right, next group. This line here, any variables or literals?
number gallons, non-gallons,
Okay, and is it a variable or literal?
variable.
Okay, next group. Okay, this one here, group behind.
MPG is a variable and 20 is literal.
Yep. Num gallons, back group.
Num gallons is a variable,
Okay.
and 2.5 is a little.
Yep. All right, this line here, back left group there.
Miles is a variable, and MPG times num gallons, that's a literal.
Okay, so in this case, like, yeah, so MPG will still be considered a variable, num gallons will also be considered a variable. I know like on this slide I typically said like typically if literal is what ends up getting stored, but not always. And this is a case where these two are still considered variables and they represent
So
a value.
it's like, it's not the whole thing becomes literal, just a variable times a variable?
Yeah, exactly. And then we kind of call this like an operator symbol. Yep. Okay. And then this group here, the cout line.
You can drive is a literal,
Okay.
miles is variable, and then that is a literal.
Okay. So miles, but again, because it's in double quotes, it becomes a literal. And does someone want to share what the output of this code will be? Yep.
You can drive 50 miles.
You can drive 50 miles. How did we get 50 for miles?
You multiply the miles is the MPG times
Okay.
gallons, which equals 50.
Okay.
20 times 2.5.
Okay, so MPG is equal to 20 based on this line, right? Num gallons is equal to 2.5 based on this one. So 20 times 2.5 is equal to 50. That gets stored in miles. Cool. Any questions on that? Yeah.
So like, would we have to put the double MPG, double gallons right in this code?
Yes, so we have to specify what the data types are when we define the variables. And in this case, like miles, like we know it could end up being a double. In this case, it ended up being 50 exactly, but we still store it as a double because they could have ended up as like 50.5 miles.
Okay, so then how come we didn't name the data type in the last string data?
Like on the previous slide?
Yeah.
Like on this code here?
Yeah, or even the one before that when we were doing the first day and
Uh-huh.
second day, we didn't put the data type.
Oh, okay. Like you're saying in the lab, like the lab problems when we just printed stuff, right? Yes. Okay. So in the labs, in lab 1, all we did was this cout statement, and we just printed out like strings. Like we just printed out string literals. So in that case, we just weren't using variables, so we didn't need to define like this data type. Yeah. Now, this week's lab is going to be a little bit more complex because now we're going to combine string literals with variables. And so now we have to define the data types for those variables. Yep. All right, any other questions? Okay, cool. So now we're going to move on to console input. So as we went over in lab, cout, you put these two less than signs, almost is like a mouth screaming out, enter your age. And so you can put like a string literal or you can put a variable after the cout. And then if we want to get input from the user, we use the special keyword cin. And in this one, it's two greater than symbols. So it's kind of the opposite. And the way I personally remember it is like you're getting like the input from the user and you're putting it into age. It kind of looks like, you know, the data is going into this age variable. So cout is sending it out to the entire world. Cin is putting it into this variable and storing it. So let's do some quick live coding just to show what this will look like. All right, we'll go into the EdStem. Lessons, and we'll go Scratchpad. Okay, so if we were to run this, cin into age. Okay, missing the semicolon. Let's run it again. Okay, so cout, it'll print enter your age. This part we should be used to from lab. And now the code is just going to stop here until the user inputs something and presses enter. Also, let me zoom in a little bit. Okay, so in this case, the user can put in something like 13, and then they have to physically press the enter button for the code to continue running. And so in this case, like we don't do anything with age, so the program just ends. But you know, if we wanted to make sure that it was actually stored, then we could do cout again and user's age, and then print out the age. So now if we were to run it again, This time we can put in a different value, 17, and it will say the user's age, 17.
Wait, can you do that again?
Yep. So the cool thing with this is that we can do, okay, so right now it's stuck at line 7, waiting to, or it's like waiting on line 8. When there's like the CN line, it has to wait for user input before it can continue. And so now at this part, we could put in a different age, something like 23, and then you press enter, and then it will move on to line 10.
So the arrow's gotta be the other way?
Yes, so for C out, it's like the arrows are pointing to the left, they're like less than symbols. And for C in, they point the other way, to the right, the greater than symbol. And it's like, you know, the data is flowing into the variable age. We're gonna get a lot of practice with this in today's lab. So kind of the way the class is structured, today is the start of week 2. So today's lab, Friday's lab, and next week's Monday's lab are all going to be focused on lab 2. Again, you can come into any lab section. So if you think there's a chance that you're gonna miss Friday's lab and you're normally in Friday lab, just come in for today's lab. And labs will always be due the following Wednesday. So especially if you want some more time to work on it, I'd encourage you to come to the Wednesday lab or the Friday lab and not hold off till Monday. If you're in Wednesday and you miss Wednesday, come in on Friday or Monday. Does that make sense? Yeah. Again, I'll always in lab go over the first problem with you all, so that can really help get people jump started and will make the rest of the lab easier. And as you saw, you have me, Trey, and David that'll be in the room to like help answer questions, which will also help you go faster in lab. So it saves you time to come in. Yep.
So does each lab have an assignment?
Yeah, so I haven't released it yet, but we have one for lab 2, and that'll be due Wednesday, August 31st. This first lab, I put a later due date just because people are changing courses, but generally you'll have 1 week for lab. Okay. Any questions before we move on to the last concept? Okay. And I think we almost have everyone completed lab 1. You need to finish lab 1 in order to do homework 1 and lab 2. With this class, everything builds on top of each other, right? In other classes, you don't do the work for 2 weeks, you'll still probably be okay. But in this class, you know, if you miss an assignment, it becomes much harder to do the next assignment. And so if you haven't finished lab 1 yet, still come in today and I can help you get lab 1 finished. Yeah?
For lab 1, do we have to do the bonus?
You don't have to. So bonus problems are always optional. It's just if you want to do it, you don't get any extra points or anything. Yeah.
I didn't do the bonus and it says I didn't complete the lab.
Okay, that's okay. Like when I'm marking it, I just look at the other 5 problems
Okay.
and I just mark it based on that. Yeah. Okay, any other questions about lab stuff? Okay. All right, so we're gonna have you all get into groups. Each group needs to have a computer, which I think we do, which is sweet. So just one computer for the group. And the challenge I'm going to have you all do is I've provided some starter code. I'll show you how to get to the starter code. And your goal is to try to break the compiler, essentially cause compiler errors by creating invalid variable names. And so in this lessons, so choose one person first off in the group who's going to be kind of the main computer person. And you can do, it could even be groups of 2, so that like groups of 4 it's tough to see. So let's just try to do like rows of tables. One person go into the EdSTEM lessons and click on the lecture 4 activity. And essentially all you're going to be doing is instead of variable name, changing it to something else. So we saw like something like player 1. If we were to run it, that works okay. If if it has the check mark, then it means the code ran properly. But if we were to do something like int, we'll do int double. And then if we were to run this, then it says like unable to build program. So, the only thing I changed was the variable name and it caused an error. If you find stuff that causes an error, raise your hand. I'll come and see it and then I'll type it up and we'll try to see just get a running list and then we'll try to find patterns from that. All right, any questions? Yeah.
I already did it.
One. Okay. I will come in here one.
I did it before class.
Okay, wait, then don't. Alright. We'll let the others figure it out themselves. Okay.
Oh, it's just,
Yep. Okay.
Just like, I guess like the,
Okay, one sec, I'll come back. Alright, so I think people have figured out you can't put a data type as a variable. Those are reserved words, so we're good there. Okay.
You can't have a number in front. You can have a number in front of the variable, so if you go like in 3, yeah.
Okay, and what happens if you put the number at the end? Is that okay?
Yeah.
Okay, so something like 3.
You can't put the characters in.
Yeah.
I guess kind of the same thing, but it's like that.
Okay. Okay, cool. I'll put that down. Okay. Cool.
No special characters.
Okay, what's an example of like? Plus? Okay. Like, do you see the plus symbol? Okay, cool.
Maybe something that's maybe variable name of quote.
Space, okay. Yep.
So, I guess, well, wait, do you have quotes already on there? Cause we do.
Okay. Cool. So that'll be, yeah, kind of like in here. Okay, cool. You all are pretty good detectives, so let's try to convert some of these examples into actual like themes. So the first one that a lot of groups figured out, you know, if you put double, int, float, bool, we can even put like namespace up here. Does someone like notice a pattern with these? Yeah.
It's things that are already defined within the system.
Yeah, so these are what we call reserved words. You might also see it defined as keywords. Actually, I think the textbook uses keywords, so we'll go with that. Keywords. Some places online will call it reserved words. Let me also make this text here. Okay, so keywords are stuff like int, bool, double, namespace. I think main. Did anyone try main in their code? I'm curious if that works or not. Main worked? Okay, interesting. Okay, I guess, yeah, then that's...
Return breaks it down.
Okay, return, that's a special keyword. Okay, yeah, so we can't name the variable these things because later in the code, if we call like, you know, double, the compiler will think you're trying to create a new data type as opposed to referencing a variable name. So we can't use these reserved words. In the reading for today's lab, we talk about, there's like one page of reading that talks about reserved words, so that'll go into a little bit more detail. All right, let's go back here. Okay, something like 3E. So we saw like player 1 works, right? So why does something like 3E not work? Yeah, so this is kind of, it feels a little bit like an arbitrary rule to me, but it can only start with like characters or underscore. Though you typically don't really see variables started with an underscore, so typically you'll only see a variable started with a character. Character being like A through Z. Okay, let's go back here. Okay, so we saw like A plus B. Someone had said like you know, if you put in a percent sign, I think a group found that doesn't work. What's the pattern with that? I think decimal 3.4 we saw above here. Yeah, so it's like operators, and then also just we'll generalize it even a little bit more to like special characters. So that's stuff like percent sign, plus sign, space. Like you can't put a space between two variables. The decimal, right? There's probably a few, oops. There's probably a few more that we're missing there, but just that idea of like, you know, these special characters you're not allowed to put in a variable name. I think we got everything. Include space 3D. Oh, okay. So in this example, some groups had put in something in double quotes. Yeah, so why does it not work if you use double quotes? I guess that technically falls under like special characters. Yep, exactly. It thinks it's a string literal, doesn't realize you're trying to define a variable. Yep. Okay, cool. And I think checking my notes, I think you got all of it. Contains white spaces, special character. Okay, I guess another special character is the exclamation point. Reserved keywords, such as int, can't be used. Names can't start with a digit. So yeah, these are the 3 ones. Yep.
Can a variable name end with an underscore? Or no?
Yes, it can end with an it can even start with an underscore. Generally though, we don't. I guess we'll see. Yeah, like you can. It's not that common to use underscores in C++ names. I know in Python it's very common to use underscores, but here we actually use something called camel casing. So I'll get to that really quick. All right, just a quick note: variable names should be descriptive. Okay, so we name variables using this concept called lower camel case. And the reason for this is that it can be confusing if you define a variable called a scent, because that could be one of 3 things, right? It could be a literal, like it could be a scent, something that you smell. It could be as cents, like if you were doing a money program and you were printing either in dollars or as cents. Or it could even just be like the word ascent, which is like going up. And so we need a way to be able to clarify what we actually mean when we define words. And to do that, we use what's called lower camel case, where the first letter of the first word is lowercase, and then every new word after that becomes capitalized. And so this helps avoid ambiguity, and it also makes the code more readable. So does someone know what this variable name is?
Long and unclear.
Okay, too easy, but you did have to think about it a little bit, and this makes it a little bit easier to read and understand. So there's 2 reasons why we do lower camel case. First, it's just that's what C++ by standard does. Second, it makes it more readable. Third, it helps us clarify what we actually mean. And so this is how we'll be defining variables in this class. Names shouldn't be too long, but they should be descriptive. So it's finding that balance between making sure it's descriptive, but not super long. Cool. So what's due? Just make sure you join the EdStem if you haven't already. Office hours today from 3 to 5. I don't want everyone coming on the last day on August 31st, so try to come one of these next few sessions. And then homework 1 will be due Monday, August 29th, and we start labs today. If you came in late and missed attendance, come up here and mark your name. And yeah, any questions? Yeah.
So I have a class at 3.
Okay.
I come at 4.
Yep. You can come anytime in that time frame. Yep. Yep.
Oh, is this where you're marking it?
I
think so, yeah.
So you can just add like a character at the end. Yeah, so it's like it's super annoying. I tried to like fix it and they said just have to put it
physics and C.
I think that was like a quick slide. So every column with output, it has to end with a new line just to like get the automated. Yeah. Yep.
Awesome.
Yeah.
Is it the same book that Watkins was using?
So
I saw like there's like a bunch of PDFs in the Google Drive, so we're using.
yeah, so just like you can download, there's one there called First Aid Chapters, so you can download that and using this class. Yep. Yep.
I need to take a turn.
Yeah, it's right down here. Yeah. Yeah. Okay. Yeah. So we can go over it now in my office. We can do it. Yeah, we can do it now.
If you wanna be in this group, you wanna make